asymptotes, guys, stop talking. Rational functions and asymptotes. How do I find the asymptote of the function f of x equals 2x over 3x squared plus 1? What are my rules that I have to follow? You have to put the bottom at the top.
Just go with you.
What? Guys, stop talking. Give me 15 minutes. That's what I said. You have to do what?
That's what I've been telling you.
No, I thought you wanted both sides or top and the bottom by like.
No, we don't do anything on side. Set what to 0? Nope.
Set the bottom to 0.
If I set the bottom to 0, that's going to give me the asymptote. It's going to give me an asymptote for what, though? Horizontal or vertical?
Horizontal.
Vertical. Any vertical asymptotes, you set the denominator equal to 0 and solve. For your horizontal asymptote, you have to look at this. This has an x here, this has an x squared. This power is smaller than this power, yes? So that means my vertical asymptote is y equals 0. When this power is smaller than this power up top, it's y equals 0. When they're equal, you set the two leading coefficients over top of each other to get your asymptote. And when there is none, then you don't have a vertical asymptote. Unless it's like if there isn't any on the bottom. To get my horizontal asymptote, I set the bottom equal to 0 and solve. So then you get 3x squared equals negative 1. You get x squared equals negative 1/3, yes? And you take the square root of that, and what happens? Radical 1/3 I. Okay. So in this case, I do not, okay.
What'd you do with the top?
What?
What'd you do with the top x? Or the 2x?
I don't do anything with the top x. To find my vertical asymptote, I look at the exponents here, and if this one's smaller than this one, my vertical asymptote is 0.
It's not zero.
Okay, yeah, you're saying it would be plus or minus negative 1/3 I, okay? But because this equation has no real solutions, the graph has no vertical asymptote. So when I solve it and it's not a real solution, it comes out to imaginary, it has no vertical asymptote, yes? Okay? Sorry, I switched these.
Wait, I thought you said,
I switched these.
okay, that's
I
what I
wrote
was
them in
saying.
the wrong
Okay, I'm
order.
about to
So
say.
it has none on this. So only has a horizontal asymptote of y equals 0.
We
It
keep
has
jingling they
vertical
bells.
asymptote.
So what if your
Hey, Cor, shut up.
horizontal asymptote is greater than your vertical asymptote in terms of the
You
efficiency?
mean what if your power is
Power is
greater?
greater than the power.
If your power is greater, then you have no horizontal asymptote. If the powers are equal like they are here, then I put the leading coefficients over top of each other, and that's my horizontal asymptote.
I got you.
So on this one, I
Then it
have
should
a
be two.
horizontal asymptote of 2,
Two,
because
right.
2 over 1 is 2.
Got you, okay.
Okay? On this one, my vertical asymptote is x squared equal, or minus 1 equals 0. So x squared equals 1. So x equals plus or minus 1. I have 2 vertical asymptotes.
Okay,
Okay? I have x equals plus or minus 1. Why is that y equals 2? Because these powers are the same, so you take the leading coefficients over top of each other to get your horizontal. So 2 over 1 gives me y equals 2. Okay? So that's how I'm solving for asymptotes. That's pretty easy in that aspect. Now, when this says find the asymptotes and holes in the graph, we'll talk about the holes in the graph in a second, but when it says find the asymptotes, what do I need to do to these two things first? Factor.
How many holes are on this graph?
I need to factor them. Okay? If I factor these, what does x squared plus x minus 2 factor to?
Positive 2, negative 1.
X plus 2, x
Yeah,
minus 1.
You're so good at those.
What about x squared minus 6 minus x minus 6?
Negative.
negative 5 minus 1.
Negative 3
Ooh,
and positive 2. So what happens is these reduce and cancel, yes?
yes.
Okay? And I get x minus 1 over x minus 3. Now, here's where my asymptotes come from. They come from what the denominator still gets set equal to 0, okay? But my holes in my graph come from what I've canceled out, okay? So I canceled out x plus 2, so x equals negative 2 is a hole in my graph. okay? It's not going to, it's not gonna have any solutions for when you plug in -2 because I canceled that stuff out, okay? So my whole is x equals -2. It cannot equal that, okay? How do you figure out your vertical and your horizontal asymptotes?
You said since they're the same, what do you say if they were the same again? You take the,
Leading
so
coefficient.
there'd just be one, or just, it'd be
Yes, it'd be 1, y equals 1 for horizontal, good.
I thought you said if there was no degree, there wasn't a.
There is a degree.
Oh.
You have to look back to the original to find your asymptote.
1/1.
So
and
y
it's really
equals 1, and what's my vertical asymptote then? What do I need to set equal to 0?
And that, so positive 3.
What'd you say? It's positive 3 because you set x minus 3 equal to 0.
I think you said the original.
I said it first, Winston, so it's okay.
Only, you need to look for the original, for the horizontal asymptote. For the vertical asymptote, I look to what I reduced because we know 2 is a hole in it, because they cancel out. Because what you would do if you did this, you would factor it first. You would get both of these, and then it would equal 3 or -2, or 3 and -2. But -2 can't be a solution because it is canceled out.
Got you.
So my vertical asymptote is x equals 3. So when you have holes, it's because things have been canceled out. Okay? Whatever was canceled is your hole. Your horizontal asymptote, you look at the original equation. Your vertical asymptote, you go off of what you've reduced. Okay? And then the last one says find the domain, vertical asymptote, and horizontal asymptote of 3x cubed plus 7x squared plus 2 over -2x cubed plus 16. What do you need to do there?
Can you set the bottom equal to 0?
Isn't the bottom a perfect cube? No, because -2 is not a perfect cube. Can you set what?
The bottom equal to 0 to find the denominator, to find the domain.
Okay, so you want to set the bottom equal to 0 to find the domain.
Yeah.
Let's start there. That's a good idea. So -2x cubed plus 16 equals 0, yes? -2x cubed equals -16. Divide by -2, x cubed equals 8. Take the cube root
2.
of 8 and you get, no, in cube roots I only get one answer.
What did I tell you, Captain?
So you get 2, okay? So your, for this, your domain is all real numbers except 2. My domain.
Barbara.
What is wrong with you? I'm so sick of you. First you called me high five. I got Walmart last night. Let's go to this.
Guys, stop.
What's wrong with you?
Your vertical asymptote, how do you decide what your vertical asymptote is?
3 over
I don't like wearing maroon
No, not your horizontal, your vertical.
I like wearing maroon pants because I feel like cold.
Get that off, Jenna. This your fault.
Vertical's gonna go with your domain, okay? Vertical has to do with your domain. Because the denominator of f has a 0 at x equals 2, and 2 is not a 0 of the numerator, the vertical asymptote is x equals 2.
I can't even remember what I'm saying.
So once I solve what my domain is, whatever my domain cannot be, it is my vertical asymptote. Because it's not gonna cross over 2. Now, Stasia, how do I find my horizontal asymptote?
3 over -2.
Beautiful. 3 over -2.
Why did you do them backwards from the last one?
What do you mean? I didn't do them
On
backwards.
the other ones you just did the horizontal one before.
Doesn't matter which way you list them. I just
I don't
list them
know.
according to this question.
Okay.
The question said domain, vertical, horizontal. I just went with that. That's fine.
Just take a deep breath.
Okay? So that is what you're working on today. Finding vertical and horizontal asymptotes, finding domains with functions. That's all. Probably go press stop, please. Let me give you some homework to work on.
We're gonna go into Java.